Good morning, children. Today we are starting a chapter, non-metals. Now, non-metals actually, if you look at your textbook, you can find so many things there, isn't it? Helium is there, then nitrogen is there, chlorine is there, isn't it? Hydrogen is there. Why only those pictures, why those things are only kept there? Hydrogen, obviously, you know, it is used for making balloons, isn't it? When you go to this festivals and all, you can see hydrogen filled balloons. Then chlorine, it is used for making a disinfecting water, purification of water. Nitrogen, used as fertilizers. All the fertilizers you can see different forms of nitrogen. In hospitals, oxygen cylinders are used. And that cylinders are filled with oxygen. It is used for artificial respiration. So, these are all belonging to the group non-metals. Lot of uses are there for non-metals. Lot of examples are there. But actually, in this chapter, we are only discussing about few of the non-metals. So first, we will get into hydrogen. We will study about hydrogen. Now, hydrogen is a major component which is seen in sun and stars. Only few amount of hydrogen can be seen in free state. The other part, water. Water is a component of carbon and water is a component of hydrogen and oxygen. So, we are going to see how hydrogen is being prepared in the laboratory. Now, if you take some zinc granules in a flask, in a round bottom flask, and you are adding hydrochloric acid to it, the reactants are zinc and HCl, hydrochloric acid. Both of them will be reacting and we will be getting zinc chloride and hydrogen. Now, if we want to confirm that the gas produced is hydrogen, just show a burning splinter on the mouth of the test tube. The hydrogen gas will be burning with a pop sound. So this, if the gas is burning or if the gas is burning with a pop sound, you can confirm that the gas is hydrogen. Now, when you look at the reaction, you can see that zinc and hydrochloric acid is a reactant. But after the reaction, you can see that hydrogen is being replaced by or hydrogen is being substituted by zinc here. Hydrogen gets removed and zinc comes together with chlorine. So a reaction in which an element is being displaced by another element is known as displacement reaction. Displacement reaction or substitution reaction. Okay, a reaction in which an element is being replaced by another element. You can call it as a displacement reaction or a substitution reaction. Now, I will show you another example. Zinc plus copper sulfate gives zinc sulfate plus copper. So here you can see zinc reacts with copper sulfate and the copper is getting replaced or displaced by zinc and zinc comes to this place, sulfate. Copper is being displaced and zinc gets substituted here. And this type of reactions are known as displacement reactions. Now, hydrogen has a variety of uses. Now, hydrogen reacts with oxygen to form water. We all know that hydrogen reacts with oxygen to form water. Similarly, hydrogen reacts with chlorine in the presence of sunlight to form hydrofluorides. Okay, these are some of the reactions that is done by that can be done by hydrogen. Now, in your textbook there is a graph shown with lot of fuels. So when 1 kilogram of each fuel is being burned, what is the amount of heat energy released? That is the graph. If you keenly observe that graph, you can find that hydrogen is giving us more heat energy when compared to other fuels. It is a cleaner fuel, totally pollution free, easily available. But still, even though we have so much about hydrogen, why is it not used as a fuel? Because if a small leakage of hydrogen happens, it can cause a high explosion, disaster. We have not yet discovered a very convenient method or accident-free method to transport hydrogen. If anyone in future finds such a way, we won't be giving much money for fuels because hydrogen is that much easily available. Oxygen is the most abundant element in the Earth's crust. You know very well how much oxygen is being used by animals, human beings, isn't it? It is found in our Earth in different forms, in the form of oxides, in the form of hydroxides, isn't it? Now we are going to see how oxygen is being prepared in the laboratory. Okay. So first what we have to take is that we have to take a boiling tube, moisture-free boiling tube. That is, it should be a dry boiling tube. Okay. Then we are adding potassium permanganate. This is a reactant here. Potassium permanganate. KMnO4. Potassium permanganate. We are taking this potassium permanganate in a dry boiling tube and we are heating it. We will be getting potassium manganate, manganese dioxide and oxygen. Okay? Potassium manganate, manganese dioxide and oxygen. So this is the method by which oxygen is being produced in the laboratory. Now likewise in hydrogen, if we want to confirm whether the gas released is oxygen, show a glowing burning matchstick or a burning splinter on the mouth of the boiling tube. The flame just burns with brightly. So it shows that the gas is oxygen. Now when you talk about some properties of oxygen, they are colorless gas, odorless gas, soluble in water, sure, supports combustion. Okay, so these are the major properties of oxygen. So here you can see that there is a single reactant here, isn't it? A single reactant. The single reactant, when heated, decomposed into 2 or 3 products. Okay? A single compound, when heated, it decomposed to give us 2 or 3 products. This type of reactions are known as decomposition reaction. Decomposition reaction. Okay. Now, if someone asks you to write the formula of oxygen, you will be writing O2 because you know oxygen is a diatomic molecule which is formed by 2 oxygen atoms. Now, there is another compound which is formed by 3 oxygen atoms. What is this compound? Yes, ozone. Okay, ozone. Now, ozone is formed as a layer in the stratosphere. This is the second layer of atmosphere. It is acting as a protective blanket preventing this harmful UV rays from entering into the Earth's surface. The oxygen which is present in the atmosphere will be absorbing the UV rays and combines with oxygen atom. That is, oxygen that using UV rays splits into oxygen atom. One oxygen atom again combines with this oxygen to form ozone. Okay, now what ozone is very unstable. What it happens? It absorbs the UV ray, split again back to oxygen. So this actually is like a cyclic process. Okay, this process goes on. But now we have been facing an issue that the ozone layer is being depleted because of the continuous use of chlorofluoro materials which contains chlorofluorocarbons. So this was a dangerous situation and we had ozone hole over Antarctica. But thank God now studies have come up that the ozone hole is being reduced. The third non-metal we are going to discuss about is nitrogen. As we all know, in the atmosphere 78% is composed of nitrogen. Nitrogen exists in a triple bond that we studied in chemical bonding. Nitrogen N triple bond N. This bond is very strong, so it is very inactive. We cannot easily break this bond. Nitrogen is more essential to plants than us. But plants are not able to absorb this nitrogen from the atmosphere because this bond has to be broken. It's very difficult. But it can happen. During heavy thunder and lightning, a lot of electrical discharge is being given out, isn't it? At a high temperature, the bond breaks, and what happens is that the nitrogen combines with atmospheric oxygen to form nitric oxide, 2NNO. It is nitric oxide. Nitrogen combines with oxygen to form nitric oxide. This nitric oxide suddenly combines with oxygen again to form nitrogen dioxide. Nitric oxide combines with oxygen to form nitrogen dioxide. This nitrogen dioxide dissolves in the rainwater to form nitric acid. Okay, this nitric acid comes down to the soil along with rain. This nitric acid, what it does is that it combines with the minerals which are present in the soil to form different salts of nitrogen. Plants can easily take up these nitrates. Okay, so this is how the plants are making use of this nitrogen. But from this, plants are getting only a little amount of nitrogen. But plants should get more nitrogen. From where do they get? For that we are using chemical fertilizers, organic fertilizers which contains lot of fertilizers like urea, ammonium nitrate, ammonium phosphate, lot of fertilizers are there. We are making use of it. This is the last element we are going to non-metal we are going to discuss, that is chlorine. Now in our homes, when we just one fine morning we are opening the tap water, when we are washing our face or when we wash our mouth, you feel that there is a smell in that water. You will say, oh, chlorine smell. Why? Why the tap water gets that smell from? Because in our municipalities and corporations, they purify water by adding chlorine. What particular property of chlorine makes them add this chlorine to this water? What is the peculiarity of chlorine? Chlorine has a particular property to disinfect germs, to purify water. Here we are going to see in your textbook, you are having a picture of how this chlorine is being prepared in the laboratory. In that we are taking a round bottom flask. In that round bottom flask, we are adding potassium permanganate and concentrated HCl, isn't it? After that, two conical flasks are kept there. Inside one conical flask there is water, and in the other one you have sulfuric acid, and then there is a cylinder which collects chlorine. So the vapor, that is the chlorine vapor is produced. The chlorine which is produced may contain some amount of hydrogen chloride. So in order to remove this hydrochloric acid vapors, first we are passing it through water. After that, the chlorine gas which is coming from the first conical flask, again it is passed to concentrated sulfuric acid. Why? Because concentrated sulfuric acid is a drying agent. It has the property to absorb moisture from the chlorine vapor. So that is why we are passing the vapors first to water and then to sulfuric acid. Now here the reactants are potassium permanganate and concentrated HCl. Products are potassium chloride, manganese chloride, water and chlorine. Now chlorine burns with a greenish yellow gas. It has a pungent odor. Okay. Then different uses of chlorine. It is used as a bleaching agent. Okay. Then it is used to prepare pesticides. It is used to purify water. It is used to prepare bleaching powder. These are the major uses of chlorine. Now, you take 3 beakers, okay, or 2 jars, not 3, 2 jars. Fill them with chlorine. Okay, both of them are dry. Fill them with chlorine. In both of them, you add colored paper, colored cloth, litmus paper, etc. Colored cloth, colored pieces of cloth, colored paper and litmus paper. Both of them. But in one jar, you add some water also. Okay, wait for some time. You can see that the color of the cloth, the color of the paper gets decolorized. It has lost its color because of the bleaching activity of chlorine. Now we are going to see how this bleaching activity is working. See here, chlorine was there in the jar. We add a little amount of water to it, isn't it? So the chlorine reacts with water to form hydrochloric acid and HOCl. This is a new word, hypochlorous acid. Okay? So chlorine reacts with water to form HCl and hypochlorous acid. This hypochlorous acid is an unstable compound. It suddenly decomposes to form HCl and oxygen. This oxygen, when we are putting them in square bracket, it is called as nascent oxygen. This nascent oxygen is very reactive. This nascent oxygen helps in the bleaching activity of chlorine. It oxidizes the color and the clothes become colorless. So this is the major bleaching activity of chlorine. Identification of chloride. Suppose you are given in a test tube a compound and you have to identify whether the compound is having chloride ion. Suppose you are having sodium chloride with you and you don't know whether it is a chloride, a given substance is chlorine or something. So what you have to do is that you add a little bit of silver nitrate to it. Okay, silver nitrate to it. This sodium chloride combines with silver nitrate to form a white earthy precipitate of silver chloride and sodium nitrate. Now, to this earthy white precipitate, if you are adding a little bit of ammonium hydroxide, this precipitate completely dissolves. So, if you are adding a little bit of silver nitrate to sodium, a solution containing chloride, a white curdy precipitate of silver chloride will be formed. To this white curdy precipitate, if you are adding a little bit of ammonium hydroxide, the precipitate will be completely soluble. Okay, thus we can confirm that the given salt contains chloride ion. Another one is that, see here, sodium is a positive ion, chloride is a negative ion, silver is a positive ion, and nitrate is a negative ion. So here, sodium goes here, isn't it? Sodium goes here, whereas silver comes here. So you can see that in this reaction, ions are getting, not one ion, both ions are getting displaced. Okay, two ions are getting displaced. So a reaction in which both the ions are getting displaced are known as double decomposition reaction. Okay, here there is another example. Silver nitrate plus potassium chloride gives potassium nitrate plus silver chloride. So silver is positive, nitrate negative. Potassium positive, chlorine negative. See, silver will be going here, potassium will be coming here. Ions are getting displaced. So these type of reactions are known as double decomposition. Not decomposition, double displacement reaction. Double displacement. So with this, our chapter is over.